Everyone knows you have a password on your wireless network to prevent eavesdroppers from listening in. Now, generally most people just have a passphrase, and that's given to everyone who needs to join the network. Now, I'll demonstrate how that works. Basically, I'll join a network that's using a pre-shared key. So if I join it, as you know, just put your password in, which I've set up here. And you're on the network. Now if you have a look at that on a Wi-Fi capture, what we see is a four-way handshake, and that's pretty much it for the negotiation of the encryption. The main drawback of this is that it's one pre-shared key for everyone. So let's say someone leaves or you don't want them to be on your network anymore. You have to change the password and then tell everyone the new password. So it's not really scalable. It's alright for home users, but enterprise doesn't use that. Now for enterprise wireless, they usually use a server such as Active Directory's NPS or Aruba's ClearPass or any other radius server really, and we can actually set one up on the Raspberry Pi to be our enterprise radius server. So to do that, we get the freeradius package. Okay, once that's installed, we want to set up freeradius to allow this access point to do authentication with it. So what we've got is we've got a supplicant here, an authenticator here, and an authentication server, which is the radius server. So we look at the config file in etc freeradius clients. Now this is for the access point to allow it to talk to it. And just go to the bottom of that and put in some config. Now you put in the IP address of the AP, but if you want, you can do pretty much a wildcard and let anything be an authenticator. Again, this is only really for a test situation. A real enterprise would have a proper setup. But just to see how it works, we'll make this AP talk to it, so secret. Now the secret is basically just a shared key kind of thing between the access point and radius. So it actually says, okay, this one's allowed to do authentication requests with the server. So we'll call the secret CW88 Wi-Fi. That'll do. Short name is any, to let any device get on there. Normally you'd call it the actual AP. That's fine. And that'll do for the client config. Now for users, we'll just make a file called users in etc freeradius. And again, I'll just jump down to the bottom of this. And we'll call it phone. And Cleartext-password is, what will I call it, phone password. That'll do. Okay, now we restart radius, service free radius restart. Okay, now that's listening and accepting requests from this AP. Now if we go to the actual AP config, even this humble little TP-Link access point can actually do radius requests. So down here where I had just a pre-shared key, we'll come up here to a non-pre-shared key. Now put in the radius server IP, which is the one we just set up, so that's 1.1.5 in this case, and the radius password, which was CWE88 Wi-Fi. That was the shared key, so they can talk to each other. And that's pretty much it. There's no username or password here now because this isn't going to do that. The radius server is. So I'll save that, and of course you've got to reboot this thing because it's how it was made. Okay, and once that reboots, we'll go through a connection to it. Okay, we'll try and connect now to that network. So if we go to Wi-Fi, pick our network. Now it's asking for an identity, anonymous identity, and a password. The identity is what we set in the users file, which was phone. The anonymous identity is here because the first part of this message is actually in the clear, so anyone listening to the Wi-Fi can actually get this username. But the real username is encrypted in a TLS tunnel, so they can't see that. If you don't put anything here, it'll just use the same one phone. But you could put pretty much anything here, doesn't matter. It's just to start that process, and after that the tunnel's built, it's secure, and then your real identity goes down that and it can't be seen. The password was phone password. Connect to that, and we're connected. Got an IP address. Beautiful. If we have a look at the packet capture for that authentication exchange, then we'll see that it starts off from the AP requesting identity, and then the phone, when it responds, the identity it gives is that one called anything, not the real one, which was phone. It's only later on from about down here. See this? We've got TLS. We have a tunnel now, and within that is where the username phone was sent. Anyway, it does all that. Says, okay, can you get on, challenge, blah blah blah, who are you, what's going on. At the end, the server responds with a success packet, okay, and then we do the four-way handshake. Now that four-way handshake is all we had on the pre-shared key version, but now that we're doing enterprise security, we've got all this extra stuff before it, and there's also radius traffic between the access point and the server. Now I've got a capture from the wired side, so that between the AP and the radius server, and you can see it's all protocol radius, which is UDP 1812, and we can see in here all these little attributes. We can see this here, that's the AP's MAC address and the SSID, the calling station, that's my phone's MAC address, the type, the radius type is 19, which is wireless 802.11, and at the end of it, you know, we get the accept, and of course we think it's the username anything, but within all that traffic within the tunnel was of course the user phone. So all it needs to send back is the accept, lets it through, and then the AP will pass traffic like any 802.1x port security. So that's how you can set up enterprise Wi-Fi on the cheap at home with a Raspberry Pi for your server and an access point from TP-Link here that can do it. So, you know, you can play around with that. Obviously it's not enterprise grade equipment, but the protocol's still the same. It's exactly the same as we saw.